For this 9-2 homework, we will be working with square roots or other roots or fractional powers and their equations. Let's start with this first example problem. In order to simplify this, you first need to know how to simplify the square root of 162. And in order to figure out how to simplify the square root of 162, you need to do a factor tree of 162. And because this is a big number, it's a bit hard to figure out, but it's an even number, right? It's divisible by 2, so let's first factor out by 2. It's 2 times 81. But then you realize, well, 81 is 9 times 9. So it's 2 times 9 times 9. Because this is 9 squared is 81. And you have a square number inside the square root that can come outside. So here's what I'm saying. You have 9 squared times 2 inside the square root, and that 9 squared, that 81, can come outside as a 9, and then square root of 2 still stays in there. Now once you have that, then you can easily simplify the fraction. So this fraction, the denominator can now be replaced by 9 radical 2, and then say, well, top and bottom are both divisible by 9, so you can divide by 9 top and bottom, which gives you 3 over square root of 2. And then you want to multiply square root of 2 top and bottom. Okay, so to repeat myself, first 27 divided by 9 is just 3. So that's same as dividing top and bottom by 9. And because the denominator is a square root, if you have a square root in the denominator, it's not considered as simplified. You always need to rationalize the denominator, which means the denominator should not have any square roots. The top can have a square root, it's just that the denominator cannot. So the result is that you have 3 square root of 2 divided by square root of 2 times square root of 2 would be just 2, because square root of 2 squared, well, let me just say it right like this. See, this thing is, you can rewrite square root of 2 times square root of 2 as square root of 2 squared, because it's same thing multiplied together, and square roots cancel and you just get 2. And that's how you get 3 radical 2. Now similar idea here, simplify. This time there's an x in there, nothing to worry about. It's the same idea. You need to simplify by rationalizing the denominator. To get rid of the square root, you just multiply that same thing top and bottom. So you take this and you multiply square root of 2x on the top, and also same thing at the bottom, because if you do that, then you end up with this itself being multiplied to itself, which is like squared, right? So this square root of 2x times square root of 2x, that's square root of 2x squared. And a square can cancel the square root, leaving you with same thing, but now the denominator is changed to just 2x. Okay, now you look at the things you can cancel. X and x can cancel. You can divide top and bottom by x. You can also divide top and bottom by 2. And the result is that you just get 4 square root of 2x. That's because 8 divided by 2 is 4. X canceled, and that's all you have. So that's the simplified version of this. Okay, more examples, very similar. Exactly same idea. You want to multiply square root of 6 top and bottom. And by now you realize that since the denominator is square root of 6 squared, the square root will go away, and you just get 18 square root of 6 on top, but the denominator will be 6. And once again, 18 and 6 are both divisible by 6. You divide top and bottom by 6, and the result is you get 3 square root of 6. Okay, now here's a challenging one. If you try to rationalize a denominator where you have two terms, they may both have square roots or just one of them, doesn't matter. If you just try to multiply 3 plus square root of 8 top and bottom, if you just multiply this much to top and also to bottom, you'll quickly see that the denominator, because this thing turns into this squared, right? And you know, when you have a plus b squared, it's a little complicated. You have to square the first one, so 3 squared, and then you also have to square the last one, which is nice because the square root will go away. But in the middle, you have to double the product, so it's 2 times 3 times square root of 8. This is what happens if you actually expanded it. If you don't believe me, you can actually write this twice and FOIL it out. You'll see that not only it creates these two, it will create this middle one as well. And that means even if you get rid of this square root right here will still stay. And that's no good. So this way of rationalizing the denominator will no longer work. Multiplying the same thing as the denominator top and bottom will only work if you just have a single square root. But if you have two numbers, you could have 2 square roots or a number plus another square root. In that case, you need a completely different strategy. And the different strategy is, let me just delete everything here. So instead of multiplying 3 plus square root of 8 top and bottom, you want to multiply 3 minus square root of 8 top and bottom. And the reason for that is because we know that the difference of two squares formula, dots formula, you know, DOTS formula, right? DOTS formula. This difference of two squares says you square one thing and subtract another square. That's same as the product of the sum and the difference, right? So you can see that this one looks exactly like this side, which means if you expanded this, if you FOILed it, you will get a squared minus b squared. So in other words, you're going to get equals to, the denominator will be not that one, but it will just be 3 squared minus square root of 8 squared. And what you get is you get 4 times this, and then you divide it by 9 minus 8, which is just 1, right? 3 squared is 9, 9 minus 8 is 1. So you just get equal to 4 times 3 times 3 minus square root of 8. And you can further simplify this by multiplying the 4 inside. So 4 times 3 will be 12 minus 3. And also because square root of 8 is 2 times radical 2. Yeah, I forgot about that. I should have noted that as well. Square root of 8 is 4 times 2, and 4 comes out as 2. So it becomes 2 radical 2, and therefore the fully simplified one would be 12 minus 6 square root of 2. Okay. So that's what you're going to get as the answer, all because of this dots formula. Okay, so just keep in mind that if you have more than one term, multiply people incorrectly call this conjugate, but I say conjugate anyways. Conjugate means you take the plus and change it to minus, or if it is minus, you make it plus. So change the middle sign. We call that conjugate. Okay. Now here we have an equation where you have a square root. How do you solve this? Well, just remember that square roots cancel if you square it. So I'm going to take this equation and I'm going to square both sides. An equation is still an equation. The equal sign is preserved as long as you're treating both sides exactly the same. So since I squared the left side and squared the right side, they should still be the same. And then you have, then you have 5x minus 6, because the square will cancel the square root, and x squared. And then moving everything to the other side, you get, keep getting this, okay. You get, if you subtract 5x both sides, and if you add 6 both sides, you get 0 equals to x squared minus 5x plus 6. And this is something you can factor. I see that 2 times 3 is 6, and 2 plus 3 is 5, but because you have a minus, it must be negative 2 and negative 3. So we get 0 equals to x minus 2, x minus 3. And for the solutions you have here, you have to set each one of them as equal. So first, if x minus 2 is equal to 0, then adding the 2 both sides gives you x equals to 2. And second, if x minus 3 is 0, that means x would be 3 by adding 3. Now, there's one more thing that you have to be careful, which is note, when solving, equation with roots, you must plug the answer back into the equation so that you can you must plug the answer back into the equation so that you can check if it works. And the reason for that is sometimes if this one is okay, you'll see that 2 and 3 both work, but sometimes when you plug this into the left side, you get a negative number inside the square root. So remember that negative number inside a square root is invalid. Okay. Also, square root can never be negative. So there are cases where you plug it in and you see that you have a square root of something equal to a negative number, then that's immediately a no-no. Or you might have something that would make the inside of the square root as negative. In those cases, we call the solution as exterior solutions. So it's not a true solution. It's like a fake solution. You have to get rid of them. Okay. So here we plug in 2, and if you look at 2 times 5, that's 10 minus 6. Square root of 4 is in fact 2, so it does work. And if you plug in 3 times 5 is 15. 15 minus 6 is 9. Square root of 9 is in fact equal to 3. So they both work, and the answer would be answer would be x equals to 2 and 3. So there are two answers in this case. In many cases, you only have one solution, or you may have no solution at all. Sometimes that happens as well. Okay. All right, number 6. So what if you have a fractional power? Remember, this 1/4 power is same as 4th root. I can try to solve this by first adding 9 both sides, which gives you 2 here, right? And then to get rid of 1/4, what you want to do is you want to take the 4th power both sides. Remember that you always need to treat both sides in the same way. You can't treat one in a different way than the other. Then if you do that, then the equality is no longer true. So, but because I took the 4th power on the left and 4th power on the right, the equal sign still works. And then if you have an exponent and another exponent like that, these two multiply. And what's 1/4 times 4? That's just 1. So in fact, they just cancel. So what I'm trying to say is that the left side just becomes 3q minus 2 to the 1st power, because 1/4 times 4 is 1. And then the right side is 16. 2 to the 4th power is 16, because 2 times 2 times 2 times 2, that's 16. And then taking the 1st power doesn't do anything. Anything to the 1st power is itself, so you just have 3q minus 2 equals to 16. Add 2 both sides, and you can divide by 3. So 18 divided by 3, which is equal to 6. So that's how it works. Okay. Now this time, this is actually a different topic. This is about solving quadratic equations. How do you solve a quadratic equation like this? Well, you just add 27 both sides. 27 plus 5, that's 32. And then divide by 8 both sides. And the important property is this. If you take the square root both sides, you get x equals to 2. But anytime you take the square away, there are two possible solutions. It could be plus or minus. Okay? That's because if x was -2, -2 squared gives you +4. A square of a negative number will give you a positive number, right? So anytime you take away a square, or even like 4th power, any even power is taken away and you got a solution, you need to put plus or minus there. On the other hand, if this was a cubed, so let's say you had x cubed equal to 8, then taking away the cubed wouldn't create plus or minus, because negative cubed will still be negative, so it wouldn't work. Okay, so just remember that if you have an even, you need plus or minus. Using the same kind of approach, you can also solve something more complicated like this one. So for this one, if I add 7 both sides, it's going to be 16, right? And then if I divide by 4 both sides, it's going to give you 16 divided by 4 would be 4. So it will be 4. And then just like before, if you take the square away, it will be plus or minus 2. So you get x plus 3 equals to plus or minus 2. And you have to solve them separately. So when x plus 3 is 2, positive 2, that means x is -1. And x plus 3 is equal to -2. Then you get x equals to -5. And they're both solutions. So the answer would be x equals to -1 and -5.